Hello and welcome. In this video we're going to solve this problem right here, and the question is to find the acceleration of the masses. Alright, so this is a pulley system, right, with a block of 2 kg connected to another block 4 kg, and it is connected by a string. Okay, so in the question we're told that the coefficient of friction, which is represented with this symbol right here, mu, is given as 0.5, and acceleration due to gravity is given as 9.8 meter per second squared. Alright, so how do we approach this question? The first thing for us to deal with is the masses. Okay, so coming to this 2 kg mass, alright, we can say that this block is going to go in this direction. And why is that? Because this is a 4 kg mass, which is greater than 2 kg. So it is going to pull this block downwards. So acceleration is going to go in this direction. Okay? So acceleration is going downwards. That's the first point we need to tackle. Now, in order to solve this, we need to go step by step. Alright, so the first step is that for block 2 kg, which is resting on a surface, let's draw it out. So we have 2 kg. Now the weight of this block is going to act downwards. Alright, and you can see the weight is going to act downwards here, and the weight is what? The mass multiplied by the acceleration due to gravity, which is 2 multiplied by 9.8, and that gives us 19.6 Newton. Alright, so for this block 2 kg, because the acceleration is going downwards in this direction, that means that the tension in the string is going to be in this direction. Okay, so our tension is this direction. Okay, and then there is a force that will oppose the motion of the block. Okay, and that is our frictional force, which is going to be in the opposite direction. So as our tension moves the string and the block downwards, right, an opposing force, which is our frictional force, opposes that motion. And our frictional force is given by mu r, which is your coefficient of friction multiplied by your normal reaction. Okay, so if the weight of the block acts downwards, the normal reaction is the equal and opposite force, right, that acts upward to the weight. Okay, so as the weight acts downwards, the normal reaction acts upward, and it is usually equal and opposite to the weight. Okay, and we also call our normal reaction our normal force. Okay, and that is equal to 19.6. Alright, so which means our frictional force is given by what? Mu is 0.5, so that is 0.5 multiplied by 19.6, and that gives us a force 9.8 Newton. Okay, now in order for us, let's remember that the question is to find the acceleration of the masses, and in order to find the acceleration, we have to consider each block separately. So let's call this block A and let's call this block B. Alright, so for mass A, or for block A, anyone you want to use. So let me just say for mass A. From Newton's law, we know that force is mass times acceleration. But in this case, we have two forces. We have the tension in the string and we have the frictional force. So we can say that the net force, let's say that is summation F. The net force is mass times acceleration. So what is the net force? The net force is going to be the greater force minus the smaller force. How do we know which force is greater? Because the tension is in this direction, right? The block goes in this direction. That means that for it to move in this direction, which has been established because 4 kg is greater than 2 kg. So for the block to move in this direction downwards, that means the tension must be greater than the frictional force. Okay, so to calculate the net force, that will be the tension in the string minus the frictional force, and that is equal to mass times acceleration. Okay, so we don't know the tension, but we know the frictional force, and we also know the mass. So that is tension minus 9.8, which we have calculated earlier, is equal to, what is our mass? Our mass is 2 kg, 2A. Alright, so let's call this equation 1. Okay, now for mass B, which is our 4 kg block, the weight of this block acts downwards, and the weight is what? mg, and that is what? The mass 4 multiplied by 9.8, which is acceleration due to gravity, and that gives us 39.2 Newton. Okay, now given that this block is going downwards, right, there is also going to be a force that will move in the opposite direction, and that is the tension in the string, alright, which is going to oppose the motion of the 4 kg block. Okay, and so this is how our tension in the string is acting upwards. Alright, so the net force, right, is mass times acceleration. What is the greater force? The greater force is the weight, because the block is moving downwards, which means that the weight must be greater than the tension. If the block is moving upwards, that means the tension is greater than the weight, but the block is moving downwards. So the weight is greater than the tension. And so our net force is the weight minus tension, and that is equal to mass times acceleration. What is our weight? Our weight is 39.2, and our tension is unknown. We've not calculated our tension. Our mass is 4 kg, so 4A. So we have equation 2. Now we can solve our equations 1 and 2 simultaneously. Okay, for uniformity, let's rewrite this as minus t plus 39.2 equals to 4A. Alright, so we have equations 1 and equation 2. Alright, so let's add equation 1 and 2 since we have t and minus t. So we're going to have t minus t to give us 0, and then minus 9.8 plus 39.2, that would give us 29.4, and that is equal to 2a plus 4a, which is 6a. And so our acceleration is equal to 29.4 divided by 6, and that is equal to 4.9 meter per second squared. Alright, and this is the acceleration of the masses, right? So this block will accelerate at 4.9 meter per second squared, and this block will also accelerate at 4.9 meter per second squared. And we can also be asked to calculate the tension in the string, and so we can simply substitute A into the equation, and we have t minus 9.8 equals to 2 multiplied by 4.9, and so this is going to be t minus 9.8 equals to, when we multiply 2 by 4.9, we have 9.8. And so t equals to 9.8 plus 9.8, and that gives us 19.6 Newton. And that is it, guys. Don't forget to subscribe if you haven't. Don't forget to like the video, share this video with your friends and classmates, and let me know in the comment section if you have any questions or concerns about the video. Goodbye. Thank you.